Hi, this is Abby. Welcome back to OpenSec. In the last video, we learned all about matrices, what they are, how to add, subtract, and multiply them. Most importantly, we learned what matrices are used for, to make it easier to do calculations that involve systems of linear equations. If you need a refresher on that, feel free to go on our last video. Now, usually, we begin our videos with a real-life example to tie into the topic of the day. However, today we are going into some abstract territory, so you're going to just have to trust the process. But remember, don't panic, it's just math. Right, the first topic for today is how to find the determinant of the matrix. Understanding what a determinant is a bit tricky. By definition, the determinant is a function that takes a square matrix as an input and produces a scalar as an output. I know that may be confusing, but all you need to know for now is how to find it, and that it can only be found for square matrices. That is, matrices with orders with an equal amount of rows and columns, like 2 by 2, 3 by 3, and 7 by 7. Finding the determinant of a matrix is really straightforward. First, let's see how a determinant is written for a matrix A. The determinant is written as DETA, or like this. DETA is found by finding the difference between the product of the diagonal from left to right and the product of the diagonal from right to left. That will give us A multiplied by D minus B multiplied by C. For example, in a matrix B with this array of numbers. Determinant B is found by finding the difference between the product of the diagonal from left to right and the product of the diagonal from right to left. That would be 4 multiplied by 3, which is 12, minus 2 multiplied by 1, which is 2. 12 minus 2 is equal to 10. The determinant of B is equal to 10. Because the determinant here is equal to 10, it means that the matrix B is a non-singular matrix. If the determinant of B happened to be 0, however, it means the matrix B would have been described as a singular matrix. Singular matrices have determinants that are equal to 0. All other determinant values are described as non-singular. One of the uses of a determinant is to determine whether a matrix has an inverse or not. A singular matrix is as single as Beyonce in 2008. She's a strong independent matrix that don't need no inverse. A non-singular matrix, however, is like Beyonce in 2019. She has an inverse. The inverse of a matrix, for example, matrix A, is written like this. A to the power of negative 1, you find the inverse of a matrix by using the determinant of said matrix as well as the adjoint of a matrix. The adjoint of a matrix is even easier to determine than the determinant of the matrix. For this matrix A, you find the adjoint by switching the position between A and D and find the opposite signs of B and C. Finally, both the adjoint and the determinant are used to find the inverse of a matrix using this formula. 1 over the determinant of A multiplied by the adjoint of A. Let's use an example. The inverse of matrix C is equal to 1 over the determinant of C multiplied by the adjoint of C. Recall how to find the determinant. That will be 1 multiplied by 5, which is 5, and negative 3 multiplied by 2, which is negative 6. 5 minus negative 6 is equal to 5 plus 6, which is equal to 11. Now recall how to find the adjoint. 1 and 5 switch places, and the signs of negative 3 and 2 are changed to their opposite signs. That leaves us with 1 over 11 multiplied by the adjoint of C, which is the array of numbers. This can be simplified further. Even though the number outside is a fraction, it is still a scalar number, which means it can be multiplied using what we learned in our last video. You multiply the scalar by each number in the matrix. That leaves us with 5 over 11, 3 over 11, negative 2 over 11, and 1 over 11. And that's how you find the inverse of a matrix. That's the end of our second video on matrices. We know the topics are getting a little heavy, but remember, don't panic, it's just math. In our next video, we are going to come full circle to the equation that started us on this journey into matrices to show why we learned to do all of this to begin with. But that's it for today. Thank you for watching OpenSec Math. This episode has been brought to you by BP, produced by the 2 Cents Movement with the help of these lovely people. Be sure to like and subscribe to our channel.